If you like what you see in this video, be sure to check out one of my instruction books, available at Amazon. The links are in the description. Hello everyone, this is S.G. DeVries, and today's video is going to be about cutting tire treads, specifically wooden tire treads for wooden models or for toys that you might be building. The most important thing about cutting tire treads for wood models is being able to make all those grooves exactly where you want them and to make them repeatable so you can keep doing it part after part, so you can get all kinds of fun sort of patterns. This is the jig that I built to do all those things. This jig will rotate 90 degrees in either direction. It will clamp down so it won't move. It slides on the table saw so that you can cut your individual treads. And it has a segmented wheel here so that you can accurately tell what angle you're cutting. The red marks on this wheel are set every 15 degrees. The blue marks are every 10, and then each of the notches is 5 degrees. So you can go down to a detail as 5-degree segments on your tire treads. If you loosen up these, this is adjustable up and down so that you can do wheels from about 1.5 inches in diameter all the way up to slightly over 6 inches in diameter. The first part of this video is I'm going to show you how it works, in case you don't have a lot of time and you just want to see it and want to see how it works. The second half of the video will be about the build process. So if you just want to skip that, that's fine. Otherwise, stick around and I'll show you that too. Let's get going. The black lines that you see on the threaded rod are the center of rotation. So any wheel that you make needs to be centered on those black lines, which I center by using 2 wing nuts just to tighten it down onto the threaded rod. I already have the angle of the jig set, and I already have the blade height set too. So once I have the wheel tightened down, I can simply just make my first cut and then rotate it by the number of degrees that I've calculated out for my tread spacing. Since the wheels I am doing here today are pretty small, I'm using 15-degree spacing between my tread cuts. So every red mark you see on the segmented wheel there is 15 degrees. So that's 3 notches for every tread that I cut. If I want my treads to slant in the other direction, for say on the other side of the toy that I'm building, I simply rotate my entire jig by that number of degrees in the other direction, and then repeat the whole process. This wheel is a little bit bigger, but I'll set my angle again, I'll check the blade height, and then I can just cut my treads like I did before. And they're done. Sometimes you want to make a really fancy pattern, so on this one I'm going to try cutting 2 patterns on the exact same wheel. Now to get this perfect you have to have that wheel dead centered, and I was being pretty fast, so my little X lines there aren't really centered on the wheel as much as I'd like them to be, but you get the idea. Now if I want to cut a groove around the circumference of the wheel, I can simply rotate the jig 90 degrees in either direction, and then use the wing nuts to slide that wheel horizontally exactly where I want it to be, and then just rotate it to cut my groove. So being able to angle that jig in either direction, you can see all the slots in this wheel are angled this way, and then in the center one they're angled this way, and then back again this way. That allows me to get all kinds of fancy patterns if I play around with the angle of that jig and with the spacing of the angles. So these two are exact mirror images of each other, which will sit on the opposite sides of the next toy that I'm building. So I'm pretty happy with the way that works. Well, that's the jig in a nutshell. These are some wheels that I built for a little skid loader that I'm making. But I'm ready to move on to the construction of the jig. So if you've watched up till now, thanks for watching. Otherwise, on to the build. The base plate of the jig is made from 3/8 inch Baltic birch plywood. Now there's a series of holes that I've measured out to hold some bearings. But the important thing to notice about this is that I need to countersink all of my holes on the bottom side because there's bolts that go through there, and I don't want the bolt heads to scratch up my saw table. On the underside of the base plate, I have glued rails to either side and to the top and the bottom, so that when I put it on my table saw, it'll fit perfect from side to side, and then also won't slide too far forward or too far back. The second major piece is the rotation plate. Now here I have marked on it already my 5-degree markings and also the place that I need to cut out. So it's a simple matter of just cutting out the circle, making it perfect, and then cutting out the center portion. So it'll fit on like this into some bearings. Now the portion that I have cut out of this is cut so that it will avoid all possible locations of that saw blade, all the way from 90 degrees in one direction to 90 degrees in the other. Before going any further, I take my pencil angle markings and I mark them in pen. Red at 15 degrees, blue at 10, and then black for the ones that are in between. These 3 plates form the main frame. Now you can see I have a groove cut in all 3 of these in exactly the same place, and then I align those grooves to make sure that the 3 plates align before I glue them together. Up both sides, good. To allow for the adjustable height of this jig, I use 4 small pieces of T-track. Now, of course, small pieces of T-track like this never have the holes exactly where you want them to be, so I just have to drill some new ones first. And then I can screw them into the grooves on either side of this frame. In order to transfer the motion from the large segmented gear down to the threaded rod, I need to use a series of gears. Now, there are whole videos about how to make wooden gears, and I'm not going to go into a great amount of detail on that, other than to say, it's not as hard as it looks. Once you've done this once, you'll realize these things are nothing scary. But you do have to make sure that the teeth work right, and usually that involves testing it out for a little bit, and then marking out which teeth are binding and do a little bit of detail sanding, maybe with a rotary tool. But really, they're not that hard. Of all the parts on this jig that have to be perfect, it's this segmented wheel. Now I did this on my computer, and there are 72 holes on this thing, all spaced 5 degrees apart, and they have to be as exact as I can make them. You know, they're not perfect, but they're close enough that you're probably not going to visually see any difference once it's done. On the back of that segmented wheel, I need to glue a small gear. Now I need to separate it just a little bit from the segmented wheel, so I build here and glue on a small wooden washer, and then on top of that wooden washer I will glue the small gear that will be used to transfer the motion down to the threaded rod. This is the plate that those gears will get mounted to. Now I didn't show measuring it out and everything, but one important thing to note is that there is a bearing that has to be put in at the bottom of this plate because the threaded rod is held perfectly in place by 2 bearings. Now that's what keeps it straight and keeps it from wiggling and makes sure that when things get clamped down, the threaded rod will still rotate right. One complete rotation of that segmented wheel results in one complete rotation of the threaded rod at the bottom. There is a second bracket that will hold the other bearing, but there's nothing really fancy about this bracket other than the holes have to align with the gear bracket. Eventually there will be a wooden handle put onto this piece of threaded rod. Right now I'm just putting it in place so that I can use it to align everything. Alright, that is dead on zero. So now the point is we've got to glue this on with this alignment straight to zero so that I know that it's perfectly straight to the rest of the piece. Small little riser pieces will get glued on to the base plate just outside the rotation plate. And these knobs can cinch down here and they can lock in my rotation position. The center marker is just simply a piece of toothpick glued into a small section of dowel. Now this center marker will get attached to the bolt that the central bearing is also on. One of the last things to build, and probably also the most weirdly shaped, is the little ratchet arm that will be used to hold the position of the segmented wheel while the cut is being made. The ratchet arm just uses a small rubber band to keep it in place. And as I mentioned earlier, the red marks are every 15 degrees and the blue marks are every 10. One other little piece I built was a small handle that I turned out of some ash just to attach to the back. And then I made sure that I marked that center of rotation. And that's the jig. You know, it looks pretty cool, but honestly, it looks harder than it really was to build. It was pretty fairly simple build. And you saw some of this at the beginning, but I am really happy with the way this works. I can make repeatable grooves now at any angle that I want, and then I know they will line up if I have a wheel that's made out of multiple discs at once. I'm really happy with it.